Okay, we want to use calculus to do uncertainty propagation. The simplest case is when we have a function of one variable. Here it's g equals f of x. X is what we measure. The function could be like sine of x squared, natural log of x, something like that. The rule says that the derivative in the uncertainty is simply the uncertainty in what we measure, the x, times the derivative of the function. Then we want to make sure this is always a positive number, so we apply quadrature. That is, we square and we take the square root. That's just the same as doing the absolute values. Most of the time, people will just write delta x df by dx and expect you to remember that it must always be a positive number. We're going to try this for a couple of examples, and then we'll do functions of several variables, which are a little more complicated. Okay, here's our first function, g equals 5x squared. So the first thing we do is we take the derivative of g with respect to x. And that's the same as 5 times 2x, which is 10x. Therefore, delta g is going to be delta x times the derivative, which is 10x. If x was a negative number, we would want to make sure we took the absolute values. That's all. Here's our next function. It's a little more complicated. It's g equals 3 sine theta cos theta. So theta is some angle we measured. Here we're going to have to use the product rule when we do the derivative. So the derivative of g with respect to theta, that's 3. Take the derivative of sine, you get cos theta. You still have a cos theta here. And then you have to do it to the extra term. 3 sine theta. Derivative of cos is negative sine theta. And that equals 3 cos squared theta minus sine squared theta. So the uncertainty in g is the uncertainty in the angle. Put the 3 outside. Cos squared theta minus sine squared theta. So as long as we can do derivatives, we can find the uncertainty in any function. That's where all the derivatives of the one variable functions that we used in 1120 and 1101 came from.